All right, so again, this is our review from the textbook for chapter 10. There will be one other review that we do tomorrow. There'll be a worksheet posted, and I will be going over that review during Wednesday's live class time. So again, right now we have the topic review that we're currently looking at is what we're focusing on today, and then the review that I'll be posting for tomorrow's assignment will be the one that we go over on Wednesday. So you need to make sure you try to get that review done and posted before we start going over it. Now, for this topic review, I didn't assign every single question on here. So, and I closed out the window that I had with the assignment listed. Hold on, let me move some things around on my screen so I can see what the assignment was. Okay, hold on, baby. Give me 1 second, guys.
Taking a picture. Look, he got a picture.
Hold on. All right, sorry about that. Okay, so we have, no, somebody's waiting in the waiting room. Okay, so topic 10. The ones I said that we are going to do was 2 through 9, 11 through 18, and then 20 through 28. So if you have questions, make sure you use the raise your hand feature so that you can stop me, ask me questions as we go. But let's go ahead and move this on down so we can first take a look at some of the vocab. So in the first part, and if you want to type in an answer and let me know if you know it, you can as we go along. So I'll pause between each question to see if you guys want to add anything in. Now, for the first part here, so it says, choose the correct term to complete each sentence. So, and blank is a region of a circle with 2 radii and an arc of the circle as borders.
You see?
Yeah.
Look,
Okay.
take that. That's off.
Okay, thank you. All right, sorry. Where was I? So on here, if we have a region of a circle with 2 radii and an arc as the 3 parts of the border, kind of looks like a piece of pizza. That's what we call a sector of a circle. So this part here is a sector of a circle. All right. Then we have number 3. And a blank is an angle with a vertex on the circle. So if the vertex is on the circle, that's what we call an inscribed angle. So inscribed angle. And that's gonna be a little too big for that, but inscribed angle, there it is. Now, number 4, a blank is the corresponding circle. Wait, blank and the corresponding circle have exactly 1 point in common. So the vocab word that goes here is going to be a tangent. So a tangent line, or a tangent from the list of words over there would be a tangent to a circle, but a tangent, I'm just going to leave it that, a tangent and the corresponding circle have exactly 1 point in common. And then 5, when both rays of an angle intersect a circle, the blank is the portion of the circle between the rays. So when both rays of an angle intersect a circle, the blank is the portion of the circle between the rays. So that is going to just be the segment of the circle. So if you're having a trouble picturing that one, I'm going to draw a picture here in just a second. A segment of a circle. So if we drew a circle, there it is. And we had some lines here. When both rays of an angle intersect a circle, is the portion of the circle between the rays. So I don't really like the way that they wrote this. Again, I think there's things that could be a better way to describe a secant, but this is the area that they are talking about on this question. I'm not going to make it that vague if it was a question on a test, but this little piece here, that's our segment. All right. Save. All right. Let's go on to some of the problems where we can actually do some work. So down here we have section 10. Now I'm going to go ahead and use my document camera so that I can do some of these questions because some of it's hard to do the work on the screen. So let me switch over what screen I'm sharing. Let's see here. Let's close this and go to, oops, not that. Share. Document camera, share. All right. So these are the problems that we're working on here. Let me zoom this out just a little bit. So number 6. It says find each arc length in terms of pi. So on this one, they gave us the arc. Now, there's more than one way that you can do this. Hold on 1 second.
Daddy, I saw.
All right, moving on. So on number 6, my bad, we got an arc that we can do this one of a couple ways. All right, they want us to find each arc length in terms of pi. So on this one, I would just use the formula that's already in degrees, which was m over 360 times 2 pi r. This was our formula for arc length. So arc length equaled m over 360, which is the fraction of the circle we're using, times 2 pi r. 2 pi r, that's the circumference of the circle. So we have 112 out of 360 times 2 pi, and the radius on here was 5. So now we have 112 over 360. I'm not sure if that's going to reduce nicely. 112 divided by 360 is, the most it will reduce down to is 14 out of 45. Then we have 2 pi and 5, so we can do 2 times 5, which is 10. So now let's go ahead and multiply. So 14 times 10, that's going to be 140. 145. We could reduce that some more. So 140 over 45, that would now be 40 divided by 45. So 28, they're both divisible by 5. So this would be an answer in terms of pi. Again, you could either write it with pi next to it like that, or you could also write it so that pi is next to the 28. If you did want this as a decimal, then we could have also actually just multiplied out pi times 3.14. On the directions for this one, again, they wanted it in terms of pi, so that would be our answer. But again, if you wanted to write it as a decimal, just so you know what it looks like, it'd be 9.769. And that was because we multiplied out 3.14. All right. On the next one there, number 7. So on number 7, we have arc ABC is the one that they want us to find. And notice they used ABC and not just AC because this time they're talking about this major arc. On this one, they only used 2 letters because it was talking about a minor arc. So now we're looking at this arc here, whereas that one, we were just looking at this piece. So for number 7, same formula. So we're going to plug it in, but this is the smaller side. So before we can do anything else, we need to subtract that off of 360. So 360 minus 154. So 360 minus 154 equals 206. So this is the measure that we're going to be using in our problem. So now we have 360, again on top, the 206 times the circumference of a circle, which is 2 pi r. I would highly recommend whenever you do your test, again, the test will be posted from Thursday to Sunday. Normally I wouldn't let you use formulas for this test, but again, I can't see that you're not using formulas. So use all the formulas you want, have them ready, have them written down so that you guys are ready for the test. And again, use your formulas. So go back through the notes. If you don't have all the formulas written down in one place, you might want to write them all down in one place. All right, so again, measure over 360 times circumference of a circle, which on this one, we know the radius is 8. So we're going to go ahead and plug in 8 for that r. So now the 206 divided by 360, we could reduce that, but only by 2. So it's not going to look very nice. But again, it wants it in terms of pi. So I'm going to go ahead and reduce it by 2. 2 times 8 is 16. Now, once we multiply this fraction by 16, it will reduce some more. So times 16. Again, it's not a very nice number, but it's going to reduce down to 412 over 45. And that could be our answer in terms of pi, which again, not the prettiest answer. If we did change it to a decimal times 3.14, it'd give us 28.75. All right. So I've done a couple questions. Are there any questions right now before I go any further? Okay, I will be there in just 1 second. Hold on 1 second, guys. All right, sorry. Hold on, Leonard keeps calling me. Let me answer this real Sorry about that. Lots of stuff is going on today, so sorry about all the interruptions. But we got, all right, number 7, we finished that one. I didn't see any questions posted. I didn't see any hands raised. Were there any questions? No. All right, let's keep going then. So now on the next part, it says find the area of each sector. So we have our area formula. All right. Give me one more moment. Sorry, guys. I got my kids at home today and I'm the only one here. So let me pause this for 1 second. I'll be back. Give me 2 minutes and I'll be right back. Yep. Okay, so number 8. Now we're doing a sector. And we're doing area of a sector. The formula is very similar, except now it was instead of this formula had our circumference formula in it. Our area formula uses the area of a circle, but it's still m over 360, but now it's pi r squared. So for number 8, we're going to have area equals m over 360 times pi r squared. Again, the directions say do it in terms of pi. So since it says in terms of pi, we're going to have to do it in terms of pi. So area equals 63 over 360 times pi 10 squared. Now, 63 over 360, now reduce a little bit to 7 over 40. And 10 squared, that's 100. So then we multiply 100, we'd have 700 over 40. We can reduce it by 10. So we'd have now 70 over 4, which those can also divide. 70 divided by 4, both of those are divisible by 2. So this is now 35 over 2. So since this one gives us a terminating decimal, because this would just be 17.5, we could write this a variety of ways. 17.5 pi is acceptable. 35 over 2 pi is acceptable. Or again, you could also put pi in the numerator, so it could be 35 pi over 2. So several different ways that you could actually do that problem. Now, for the one right next to it, same idea, same concept. Let me just slide this over. I'm going to do number 9 right next to it. So we have sector DSE. And for sector DSE, again, that is name, there's a typo there. Well, no, that's okay. They should really tell us a shaded region though, because that is a poor way of labeling it since it's that angle. A lot of times, a lot of other books would say the sector that's shaded or the sector that's defined by the regions with the 2 radii and an arc, because really there's 2 angles here, but we're going to do based off this angle right now for the purpose of this problem. So we have 172 over 360 times pi r squared. So 172 divided by 360. We could simplify that down to 43 and 90. So we divided both of those by 4. The r, I forgot to plug that in. The r in this one was 7. So it's going to be 7 squared, which is 49. So now 43 times 49, that's 2,107 over 90. I'm not sure if that will reduce at all. Nope, that won't reduce. That's our final answer in terms of pi. Now, again, these ask for in terms of pi. If you were to not leave in terms of pi, we could have multiplied each one of these answers by 3.14 times 3.14. This would be 73.5. On this one, if I multiply that by 3.14, that'd be 54.95. And those would be our answers. All right, anybody have questions on those two? No? All right, 10, I did not have you guys doing. So I said 11 through 18 for the next part. So let me move that out of the way. I'm gonna take these down. All right. On the next set here, this is now asking us QR and AB are tangent to the circle. Find each value. So in this one, they want us to find the length of QR. So I'm going to go ahead and highlight the part that we're trying to find. Now, they gave us this piece was 7, this piece was 6. So we know that this entire length is 13. We also know that the radius here was 7. So the radius anywhere in the circle is 7. So the radius here is also 7. So we have two sides of this triangle, and this is a right triangle if this is a tangent. So now we can use Pythagorean theorem. So for number 11, I don't recognize the name. Hold on. Let me message the person in the waiting room because I don't know who that is. It might be somebody on a parent's. Give me a second. Let me message him. It might be Adrian. Yeah. Oh, okay, go. I'll be in there in a second. Okay, all right. Hold on 1 second. Guys, I'll be so okay, let me finish this one problem and then I'm gonna go take care of something. So where was it? Number 11. So number 11, we have Pythagorean theorem. C squared equals A squared plus B squared. So C squared, that's our hypotenuse again, so 13 squared equals, this side was 7 squared, plus our unknown side is going to be B squared. So I'm going to call that X over there, X squared. Now, 13 squared is going to give us 169, 49, subtract off the 49, leaves us with 120. Take the square root of both sides. Now, it did not say how it wanted us to leave our final answer here, but Since the other values were exact values, I think that they'd want an exact value here as well. So this is not a perfect square. However, we can take the square root of a number that goes into that, which, let's see, I know 4 goes into that. I'm trying to think if there's any other numbers that go into that one. Divided by 4. 30, so that'd be 10, 3. No, I think 4 is the smallest number. So we have 4 and 30. Square root of 4 is 2. So that's 2 radical 30. So that could be our answer, 2 radical 30. If we wanted to do it as a decimal, when we take the square root of 120, it would also give you 10.95 as a rounded answer. So this is the exact value. This is a rounded answer. All right. On number 12, this time they're looking for an angle, CAB. CAB. So they want this angle. I'm highlighting over here. I'm going to put X in that corner. Now this is a fast one to do because this is a right angle. So if that's a right angle, all 3 angles in a triangle have to add up to 180. So for number 12, we're just going to simply say 180 minus the 2 angles that we know. So 180 minus 58 minus 90 is 32. So those are number 11 and number 12. I'll be right back. Gotta take care of something. Hold on. Now, again, if you guys have to go, I know that normally I like to not do over 45 minutes, and we're approaching that 45 minutes right now. If you have to go, that's fine. Again, I'm going to keep going. I'm going to keep going over this. I'm going to end up posting it to YouTube. If you have questions, go ahead, stick around. But if you have another class to get to, again, you're more than welcome to go. Sorry, things have been a little crazy today, but that's life. So moving on, we have 11 and 12, 13 and 14. So on 13 and 14, here we are going to be doing, 14 says construct. We're not doing constructions. Is that one of the ones I said to skip? No. Okay, so should have been one that I had you skip because that one is a construction question. But we can answer it. It actually doesn't make you construct it. Let's actually go ahead and do it real fast. I lied. If GH is a diameter of circle T, is it possible to draw tangents to G and H from the same exterior point? So what they're saying, and let's just draw a circle here. So if we had a circle and we drew a diameter through it, and we had a point G and a point H, and this was T, and then we had an exterior point. So we need an exterior point out there that would have a tangent line that goes through G and H. Is that possible? Well, in order for a line to be tangent at point H, it's going to have to be a right angle. In order to have a tangent line at G, it's also going to have to be a right angle. So these 2 lines end up being parallel. Therefore, they will never intersect at a common point outside the circle. So the correct answer for number 13 is no. And again, it's because the tangent lines at points G and H would be parallel, so they would not intersect. Tangent lines at point G and point H would be parallel, so they can't intersect. All right, so that'd be a good reason on that one. All right, let's go to 14. On number 14, segment MN is tangent to circle L. All right, so they're telling us that this is a tangent, so we can go ahead and throw in that right angle. What is the radius of the circle? So we don't know what the radius is, and they only told us that this piece is X. So this piece is also X, because again, they're both the radius. This entire side is going to be 5 plus X. Now, this one's a little bit harder because it may turn into a quadratic. And it may turn into a quadratic that's a little bit harder to solve. So on this one, we have Pythagorean theorem, just like we had on the problem on number 11. C squared equals A squared plus B squared. Our C squared value, though, this time is 5 plus X squared. And our A value could just be the X. Our B value could be 8. And then we had to solve this. So now, if we solve this, this is still X squared. This is now 64 on this side. When you multiply this out, this is the same thing as doing two binomials being multiplied to each other. So when you multiply this out, you end up with 25 is 5 times 5, and then 5 times X is 5X, and then X times 5 is 5X, X times X is X squared. Again, we did our distributive property. So using a little bit of algebra. So this is now 25 plus 10X plus X squared equals X squared plus 64. Now, although we have a quadratic, this one actually turns out nice because we have X squared on both sides. We can subtract it off, cancels off on both sides. We no longer have an X squared, and we're no longer dealing with a quadratic. So 25 plus 10X equals 64. Bringing the 25 across. 64 minus the 25 leaves us with 39. And then divide by 10, and X is 3.9. And that is our radius, because we made our radius X. All right, let's go on to the next one. So that was 14. Let me set these answers off to the side. I'll post all these answers later. All right, 15. Some of these get a little bit easier as we go and don't require as much work. I think we got through some of the harder ones already. So now we have, for 15 through 17, it tells us that we have circle T. Now the radius is 7. They didn't write that in the circle anywhere. Find each value round to the nearest tenth. So FH, they want this piece here. Well, they told us that that piece over there is 5, and there's a lot of pieces in here that have to be congruent. So if that's 5, this piece is also 5. And they told us that the whole radius is 7. So if this whole thing is 7, that means that this little piece is 2. Then we have CD. So number 15, all we actually did was 7 minus 5, and that gave us 2. Number 16, CD. That's this piece here. Well, we don't have that whole thing, but we do know the radius is 7. So this is 7. So I'm going to go ahead and use this triangle here. That's a right triangle. So we have our C squared equals A squared plus B squared. And we have C is going to be the 7. We can use 5 there. And then we don't know what B squared is yet. 7 squared is 49. 5 squared is 25. Subtract off the 25. So we had 49 minus 25. That's 24 squared equals B squared. Oops, sorry, not squared. 24 equals B squared. Square root both sides. And we get, now it says round to the nearest tenth, so we can go ahead and round here. So square root of 24, if we had simplified it, was this. But again, we're going to go ahead and write it as a decimal since it says round. Now, this is not our final answer, so I'm going to leave a couple extra decimals for a moment because this is only this piece. I'll be right there. That's only this piece right here. We want the entire thing CD, so we have to times this by 2. So double that. We get 9.797958 and a bunch of other decimals. They want us to round to nearest tenth. So just one decimal place. So this is 9.8. Then on number 17, we have measure angle BTA. Well, this angle here, it looks like it's a right angle, but we can't assume that. But we do know that this arc is 44. Well, guess what? All these arcs, all these little arcs are 44. So this entire arc over here, 44 and 44 is 88. So this angle here, that's a central angle. That's the same as the arc it's intercepting. So this entire thing is also 88. So again, for number 17, all we did was add 44 plus 44 and got 88. Do we have 18 as one of the ones we're doing? Yes. So on 18, number 18, it says circles T and S intersect at points A and B. What is the relationship between AB and TS? So let's see what this looks like. If we had two circles intersecting at two different points, A and B, T and S, what is the relationship between AB and TS? Well, I think what they want you to say is that this is going to be TS will be a perpendicular bisector of AB. TS is a perpendicular bisector of AB. Right. So that one you kind of draw out to see it. All right, moving on. Next set was 20 through 28. Number 20. So on number 20, what time is it? I do have another class that's going to be starting here shortly, so I may have to cut this off and finish the last part of this video later. So on number 20, we have these angles that are marked. They want EF, so they want this arc here. Well, we know that these two that they're labeling are going to be congruent because they're intersecting the same arc. So we're going to set those equal first. 9x minus 6. Solve, I'm going to bring the 5x over that way. I'm going to bring the 6 over the other way. So plus 6, plus 6. So now we have 4x, and this is 20. Divide by 4, x is 5. So if we plug it back into either one of those, we should get the same number. So 5 times 5 plus 14. And that's going to be 25 plus 14, which is 39. Now, oh, that's not the final answer yet. Hold on. They wanted not the angle, but the arc. The arc is going to be double that angle, so times 2. So that would be 78 degrees for the arc. Okay, then we have number 21. Move that out of the way. So I know I'm picking up speed a little bit, going a little faster. like I said, I will post everything. Move that over. So on number 21 now, we have, let me go back and explain that last one real fast because I think I might have cut that off the picture. I'm not 100% sure. So on number 20, again, these two angles intersect that same arc. So they had to be congruent. So I took those two measures, set them equal, solved for x, plugged it back in for one of the angles, got the angle measure of 39 degrees for both of those angles, and then multiplied it by 2 to get the arc. Because again, the arc is twice the measure of an inscribed angle. And that's an angle on a circle. All right, now let's go on. So on 21, we have the measure of MNP. MNP. So they want this angle. Let me go ahead and highlight it before we forget which angle we're talking about. So I'm going to call that angle X. Now, there's lots of stuff going on in this diagram. They gave us, which angle is that pointing at? It looks like it's pointing at this angle. So if that's this angle, 51. We know this measurement would be double that. So this would be 102. Because again, the arc is double the angle. And then we also know that this is 63. So then we should be able to find this piece because we can subtract from 360 because all the arcs have to add up to 360. So 360 minus the 102 minus the 163. 360 minus 102 minus, what was the other measure? 163. That's 95. So now that we have 95, that's going to be this arc. We want the angle, so we got to divide that in half. So divide by 2 gives us 47.5. And that'll be our answer. Now, on 22. All right, lots of stuff is happening here. They want measure of WZY. Well, the important thing to remember here is if you have an inscribed quadrilateral, the opposite angles are going to be supplementary. So the 6x and the 9x have to add up to 180. 6x plus 9x equals 180. Once you know that, we can solve for x. So 6x and 9x gives us 15x. Divide 180 by 15, and you get 12. So now that we know that that's 12, we can plug it in for the other angle, angle x here. 8 times 12 plus 5. 8 times 12 plus 5 equals 101. And x and z are also across from each other, so they too should be supplementary. So 180 minus 101 is going to leave us with 79 degrees for angle Z. And that's it. All right, 23. Let me scoot that up. Number 23. All right, we have QPR. So we're looking at this angle here. All right, things that we know. We know we have 59. We know we have 71. All right. You might not see this right away, but the two angles that I'm highlighting here, so the original angle I highlighted and this angle, are intersecting this same arc over here. So that means that these two must be congruent. So if we can find this angle, we know that angle. We have two angles of a triangle. All three have to add up to 180. So 180 minus the 71 minus the 59. 180 minus 71 minus 59 leaves us with 50. And that's our answer. All right. 24. Let's scoot it over so we can read it. If a rectangle is inscribed in a circle, what must be true about the diagonals of the rectangle? So if it was inscribed into, since the angles are all right angles, that means that the diagonals would have to be diameters, because if you have a right angle inscribed into a circle, that it's actually going to be inscribed into a semicircle because it's going at the ends of the diameter. So I have to draw a picture for this. Again, if we were to draw a rectangle and draw on the diagonals, wherever they're crossing at the center of the circle, because each of these is a 90-degree angle. Anytime there is a right angle, it is inscribed into a semicircle. So what's true about the diagonals? They are the diameters of a circle. They would be diameters. All right. Let's go on to 25. I'm going to finish this. I don't see anybody's trying to sign in for my next class, so I'll start my next class a little late. I'll send out a reminder. People probably forgot since it's a Monday. QR. So for QR, we have that little segment there. Well, these are intersecting inside of a circle. So if we take, again, the two parts of the same line, they should be equal to the two parts of the line multiplied together. So 5 times 12 equals, I'm going to call this x, 10 times x. So this is 60. This is 10x. Divide by 10, and x is 6. And that's the piece that we're trying to find. The measure of angle NRP, well, they gave us this angle and this angle. These two arcs is what they gave us. These two angles are congruent. And since we have intersection inside of a circle, it's the average of the sums of those two arcs. So for number 26, we're doing 43 plus 81 divided by 2. Again, averaging the two arcs. So 43 plus 81 is 124, and 124 divided by 2 is 62. On 27, now notice our intersection is on the outside of the circle. For number 27, we have some different rules to follow. It looks like I have one person trying to join for my next class. Let them know that I'm running a few minutes late. Send to waiting room. Okay, so I only have one person in the waiting room, so I will finish these last two problems before we end this. All right, 27, WZ. WZ is this piece here. Again, when it's listed like that, that wants the length of that piece. Well, that's a tangent line. So we're using the equation, the tangent squared equals the exterior times the whole. Well, in this case, the whole on this side is 10 plus 8, so that's 18. The exterior is 8. The tangent is what we're looking for, so I'm going to call that x. X squared equals 8 times 18. 8 times 18 is 144. So we're going to have the square root of 144 is 12. All right. Now, last problem, 28. All right, this is the last one. Yeah, this is the last one I asked you guys to complete. So on number 28, we have the arc XZ. So now the intersection is on the outside of the circle. We're going to be doing our other formula, which is the measure of the angle is equal to the big arc minus the little arc divided by 2. So we have the angle measure is 74. We have the big arc is 187. We don't know the little arc. I'm going to go ahead and label that as y for right now. So solving this using algebra, we're going to have the 2. We can multiply it over to the other side. So times 2 times 2. So 74 times 2 gives us 148. Subtract off the 187 minus 187. So minus 187. That's negative 39 equals negative y. So just change it to a positive. And we have our answer. All right. That's it for today. All right. I'm going to go ahead and end this meeting. That's our final answer, positive 39. I'm ending this meeting. I'll post it to YouTube. I'll take any questions during tutoring tomorrow. And I will see you then. All right. Have a good one. And again, I'll post the new review for Tuesday tomorrow as well. All right. Let me stop this recording.